My name is JD Houchens. I work for Code 661 in NSWC Carderock. I'm a mechanical engineer for the Underwater Explosion Research and Development branch. Today we're at the B-Bay Annex at Building 19 at Carderock. Right now we're doing some lightweight impact testing for different kinds of fasteners and bolted connections. Our goal here is to assess bolted connections under dynamic loads. It's really important for the Navy to understand how different bolted connections behave under different types of loads. And the lightweight shock machine is an ideal environment to test these specimens. So this machine goes about creating a dynamic loading environment for bolted connections by raising a hammer-style pendulum at a specified height of our choosing. That will allow us to adjust the kind of energy that we need to impart into the bolted connection. That hammer strikes the machine and imparts an impulsive load, and that impulsive load is transferred to our test specimen. The different types of specimens that we're testing are common types of bolted connections that you would see used in Navy application. We're looking at the standard socket and hex head type bolt, all the way to more specialized fittings like flatheads and countersunk style fittings. Also varying a few other critical variables like material and manufacturing process. Some of the materials that we're looking at are anti-corrosive materials that are used in Navy application to high strength steels. This capability, this test machine has been useful for us to provide dynamic data that otherwise really hasn't been investigated across the Navy. So it's really kind of paving the way to understanding how different types of fasteners and bolted connections would behave under a severe dynamic load such as a shock load. We're hoping that our research will help the Navy save time and money across future applications of ship classes and submarines.